me record this. There we go, so we can get this uploaded afterwards, because I know people were asking. Yeah, TikTok's just not going to cooperate with me. That's really sad. That's why. Yo, I made it work. Yes. Alright, boom. Alright. We're good to go. I'm gonna mute this. Don't mind that voice crack. One more second, guys. I promise we're gonna start. Technical difficulties. In the meantime, I can't lie, if you've got anything specific, and I just got some notifications on my phone as well, I will check those. Hello guys on TikTok. But you guys cannot see anything. Wait. I'm gonna change the screen. Display 3. Wrong one. Yeah, I can't. That's calm. I could change it to display 1. You can see my face. Actually, yeah, I'll leave it like this on TikTok. Guys on TikTok, I'm not gonna be replying to you. So you're just gonna be in the background. So yeah, if you want to join through the YouTube. Just go into my bio and just come from there. Okay, let's get started, guys. Let's get started. Okay, I'm gonna do a quick introduction for the guys that don't know me. I'm Anas. I'm a gap year student, actually. I'm going to university this September, so I'm actually going with you guys, believe it or not. But you might be like, okay, so why am I learning from this guy? Okay, what does he have? Okay, I've got 3 A stars in maths, chemistry, further maths, and I also got an A in bio. The original plan was I was going to become a med student, well, dentistry student. That didn't go very well. There's a big story behind that. But now I'm doing LSE economics, so yeah, that's the big plan this September, anyways. In terms of maths, I'm very happy with the fact that I got 94%. I am very confident in the way that I can teach. I've got many students here today as well in the chat right now if you want to say hi. No, we're not cooked. Oh, we cooked. Yeah, we cooked. It was 1 mark away from A star. I did get remarked, but yeah, they didn't give me, man. But it is what it is. We move. Yeah, I've got many students. I've been teaching for like 4 years. I started like year 11 time. But yeah, what made me choose economics? Good question, Reeb. Good question, man. I can't lie, it's all about the money, bro. Bills pay yeah, bills pay. Money pays the bills. Okay, let's get started. If there's any questions, yeah, make sure you ask. Talk in the chat and tell me you don't understand. Yeah, if you don't understand it, you need to say you don't understand it. That's the whole essence of teaching. Okay, because what happens is, in class, by the way, we're going to start with a simple warm-up, by the way. And yes, Abby, OCR is going to be is used for OCR, used for AQA. Even if you do WJEC, pure is essentially, it's just maths. Same with sciences. They're all essentially kind of they follow the same spec. Okay, we're gonna follow this question here. Easy. Partway. We're gonna have a yeah. This is Edexcel right now. This is a mock paper actually. No, we're not going through just a paper. You did this yesterday. We're just gonna have a bit of a warm up, but I have loads of different questions planned. We're gonna be doing geometry as well. By the way, in the 2024 paper, where can you find this paper? If you just search up mock set 3, this is June 2019 mock set 3, or you don't have to necessarily have the question with you. Just write it on paper. Just do dy by dx. Just a quick warm up, and then we'll start to look at some more harder questions. Okay, we're just gonna have a quick warm up here. Madas is really good. Very nice animation saying it is going to be 3x squared minus 14x plus 5. I'm not going to explain why. If you are unsure, make sure you are up onto your differentiation. This is the 1 differentiation. Yes, this will be uploaded as a live later on. Okay. Secondly, tangent at P. Now, if this is your dy by dx, we're going to substitute this corner in, and then we're going to end up with the gradient. I'm pretty sure this should be pretty simple as well. If we substitute dy by dx, sorry, x equals 2, we should end up with 4 times 3, which is 12, 14 times 2, which is minus 28, plus 5, whatever that gives you, no idea, it's a mental maths here, minus 16 plus 5, that gives you minus 11, check, that's my mental maths, any good? Nah? Minus 7, alright, cool. And then we have y equals mx plus c. You might be taught in different ways. I know some teachers teach with y minus y1. If you ever use y minus y1, always convert at the end to y equals mx plus c, even if it doesn't say so. You will lose marks if you don't. Okay, it's not a bit of a flex. I'm actually gonna make a bit of a flex here. I've literally studied the mark schemes inside and out. Like I've done for stats, for mechanics, and I've kind of like made cheated ways. I mean, I think having the graphical calculator is helpful as well. But yeah, it's easy, looks good. Minus 11x plus 16. Just make sure you sub in the minus 11 into your y equals mx plus c. You have your 6 minus 6 here, and essentially we're going to rearrange. I'm just going to double check this. I'm sure you're correct though. Plus c. We're going to sub in x equals 2. And if there's any questions, just make sure you're asking. Minus 6 is equal to minus 22 plus c. That gives you c is equal to 16. Amazing. Alright. I feel like that's pretty simple. I'm going to skip past a lot of these. And actually, I'm actually going to focus on... actually, I'm not going to look at this question. I'm actually going to focus on range of domain for a bit. Because I know I seen a comment yesterday. And a lot of people, I feel like, struggle with range of domain. And I think it's even harder because a lot of the students in the country, they have the graphical calculator, but at the same time I know a lot don't. So I know it says find the range. I'm gonna make another question like a part D. And by the way, I'm eating some snacks as well. If you got some snacks, just eat along. How many people? 188. This is from actually I have no idea where this is from, I'm not gonna lie. Yesterday and a couple of days before, I just made like a bunch of questions. Just can simplify kind of the notes. Okay, the video will be recorded afterwards as well, uploaded afterwards. Alright. Have a go. Start with it. I'm gonna give you guys like 2 minutes, 2-3 minutes for the first question. If you've got an answer, just put it in chat. Sorry guys. Alright. I'm gonna put a timer on screen. Yeah. Let me look on TikTok as well if there's anything. Oh, there's 99 guys. Yo, guys, I'm not replying on TikTok, by the way. So if you guys want to come from TikTok to the YouTube, come to my bio. That way, you guys can actually see me as well, because you guys can't see my face on there. So yeah, if you're on TikTok, just come on over to YouTube. Okay. F is less or equal to 9. That's one of the answers. We got less than 9 as well. Okay, yeah, equal to good, Fred. Yeah, I'm literally going to do that now, Thanish. We're going to do that. I'm going to make... If you've done part B and C as well, I want you guys to attempt... not that, actually. Gf of x. Range... I'm going to see how this goes, actually. Range of Gf of x. If you've done part A, B, and C, or if you think part B and C are easy, jump to part D. Where can you go through topics quickly? You can just search. I think Madis is really good, Dullah. Just search like hard differentiation questions into Google and see what comes up, and then you also have like Madis math stuff as well. Okay, I'm gonna go through part A. Part A, essentially it's a quadratic. I think making stuff visual as well can really help. Well, x squared looks like a graph like this. Minus x squared will be your sad face. And if you think about, well, your transformations, if you're minus x squared and you move it up by 9, it's just going to end up around here. And what is this coordinate here? Your y-intercept is 9. Well, your range is going to be everything less than 9. Or equal to 9 as well. So your range for f of x for part A should be less than equal to 9. Okay, part B, I'm going to also go through now. Part B, we're going to sub in 1.5 into g of x. I think this is a simpler way. You can do the composite function first. I think that's a bit long though. sub 1.5 into g of x, and I'm actually going to pull out my calculator as well. I should really bring it on screen. 1 second, but I'll type it into my calculator as well. Guys on TikTok, I'm going to keep on saying it because I'm not really watching the chat there. Just hop over to YouTube, that way I can actually see your chat. Okay. Okay, you guys can see my calculator now, which is good. This is the chunky calculator, by the way. It's so OP. I'm not gonna lie. Who said that? Mr. Bombastic. I think someone said maths pay to win. I can't lie. There is a pay to win factor, but you can't use it in uni. So yeah, my school, anyways, what they did was you could rent it out essentially. I think it was £15 for 2 years, and then yeah, I think it was quite useful. I know some schools, they don't tell you to do that at all, but I think if you get the hang of it, it's really useful. Now I've essentially put 1.5 into g of x, and then we just bring this function back into f of x. So your final answer for fg 1.5 should be the following. I know this is some easy stuff right now. We're going to definitely up the difficulty, so stay around. It should be 135 over 16. Okay, I'm going to also speed through g to the -1, and we're going to really focus on how to do this range thing here. G to the -1, I'm just going to do y equals, y equals 3 over 2x plus, oh, I'm tripping, x equals 3 over 2y plus 1. I've just swapped the variables. Then I'm going to rearrange for y. So this gives me 2y plus 1 is equal to 3 over x. That gives me 2y, you guys cannot see that on YouTube, oops. If there's any questions, just make sure you guys are asking. 2y plus 1 is equal to 3 over x. I've just swapped the denominators and the bit there. Yes, Lewis is being uploaded later. 2y is equal to 3 over x minus 1, but I'm actually going to rewrite it like this just to make it look a bit more nicer. And that means that y is equal to 3 minus x over 2x, and that means that my inverse function is just going to be this. Do we need to include the domain? Very good point. You do. It is a 3 marker, and if you see the 3 marks, it's not normally clear. So your domain, well, we can find out the range pretty easily. The range of this is just going to be bigger than 0. Okay, so g minus 1x is just going to be bigger than or equal to 0, because your inverse function and your domain stuff, your domain and your range swap when we talk about inverse functions. Okay, we need to think about, okay, well, what is our range for this? We already worked out the range of f of x, which is f of x is less than or equal to 9. We worked that out. Okay. Now what we need to think about is, well, we're taking this and we're substituting it into our g function. Well, if I take my domain, let's start with the domain first, just the domain. If I take my domain and I'm placing my f of x function into my g of x function, which causes this compound function. Okay. If our domain is x is bigger than 0 on our left hand side and x is bigger than 0 on our right hand side, our domain is just going to stay the same, which is x is bigger than 0. Or, well, technically, yeah, x is bigger than or equal to 0. Do we agree with that? F of x is bigger than 0, g of x is bigger than or equal to 0. They're happening at the same time, so that means our domain is going to be bigger than or equal to 0. Yes or no? I'm going to take that as a yes. No one has said no. Okay. That's our domain, but the question's about range. Okay. Now, let's make an expression for what g f of x is. Usually I'm going to say it's probably 3 marks. No? No? People said no? Why are we getting no? You're having x is bigger than 0 from our first expression. G of x is bigger than 0, and we're having it at the same time. Then, let's make an expression for g f. This is a separate question. You guys are thinking about our previous question here. You're thinking about part C here. I'm talking about part D. We're trying to find the range of the compound function. Okay. So this is a completely separate question. We're doing the domain and range right now. Yeah, we'll look at that as well in a second, Lexi. I've got a couple down here, I believe so. If they weren't, we'll look at that. You're lost. Why are you guys lost? If you have your domain at x is bigger than 0, just the domain from the question, and your question from g of x is also bigger than equal to 0, them happening at the same time is still going to be x is bigger than 0. Yes? Now, if I make an expression, has anyone worked out an expression for g f of x? Has anyone worked out an expression for that? Just to save some time. I'm gonna check on TikTok as well. Maybe it's. I'm gonna work it out. You guys. You have to come in. Yeah, exactly, BMD. F of x. I'm gonna take f of x. So this gives me 3 over 2. Amazing, James. Thank you very much. 3 over 19 minus 2x squared. Okay. Now, this is our expression, and now we need to think about what is our maximum value and what is our minimum value. Now, if you have the graphical calculator, amazing. It's going to be really helpful for you. However, if you don't, this is the way you're going to do it. We need to think about, in this expression here, what's the maximum or minimum this value can be. Okay, and a good way of thinking about it is your turning points. I would avoid doing any sort of differentiation when you think about turning points. The reason why I'm saying that is I want you to rather think of it in terms of a complete the square type of thing. Okay. Now, minus 2x squared plus 19. I'm gonna rearrange it like this. It's the same thing. Yes, BMZ. It's biggest when the denominator is smallest, and I'll get to that for those who do not understand. Okay. So if I draw this, essentially what this will look like is this. And if you're unsure on how to get this sort of thing, think about what x squared looks like, which is a smiley face. Minus x squared will be a sad face. And then when you add 19, you're just going to shift it up by 19. The reason why I haven't taken account of the 2 is because it just stretches vertically anyways. It doesn't really make a difference. Okay, but if we're adding 19, our highest point up here will be 19. If you have a quadratic that you can't do that as easily, then you're going to do complete the square and work out the turning point. Okay, essentially we worked out the turning point, which is going to be 19. Does that make sense? And the reason why we've done that, the reason we worked out the turning point is because in this case it's the maximum. Is this top one supposed to be x squared, not minus? What do you mean, ZZ? Have I done something wrong? I just took this from the chat, unless we've got the wrong the graph I made. The graph I made. Oh, sorry. Yeah, you're right. You are right. Yeah. You're absolutely right. Yeah, x squared. Yeah, you're right. But anyways, the reason we're trying to find the maximum point is so that we're able to see the minimum. When you have a really big denominator, something happens to it. When you have a really big denominator, what happens to your yes, Roham, it is a reciprocal graph, but the reason we're focusing on is what does this look like? When you have a big denominator, what happens to your fraction? Tends to 0. Good, thank you, Finn. Okay, when you're looking at a big denominator, it tends to 0. However, what's our maximum point here? What is our maximum point on our quadratic? Good, 19. So if our maximum point on our quadratic is 19, that means this is the smallest our fraction can be. Bigger the denominator, smaller the fraction. Cool? This is our smallest value in this case. Now, what is our... If we continue to decrease the denominator, what happens to your fraction if we make our denominator really small? If if we make our denominator really, really small, our fraction will tend to infinity. It will get big. But in this case, you can see we don't have a minimum value. It just keeps on going down, 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 down. So that means that essentially we have 3 over infinity, which tends to, sorry, a 3 over, I'm going to say 3 over 0, tends to 0, which tends to infinity. It is bigger, gf of x is bigger than, yep, whoever said that in chat, you're absolutely right, it's bigger than 3 over 19, and this would be less than 0. And we can see this, look at this visually. Oops, where is it gone? Here we go. It continues to increase because this is our smallest value, and it continues to decrease because we have no minimum value. Does that make sense? It's a complicated topic. It is a complicated topic. But the more you do it, it makes you better at it. I wouldn't fuss over it at this point in time. Honestly, I wouldn't. Rage baited. Alright, let's move on, because I'm looking at time. How would you apply this when you have an x value for the turning point which is not equal to 0? Good question, Ahaz. How do we know the decimals we get is 3 over 19? It's because this is your smallest value it can be. So if this is your smallest value it can be, everything has to be bigger than it. Does that make sense? Okay. If you had someone asked, what if it's like a 2x squared plus 19? What if it's not that? What if it's a quadratic that looks like something else? Let's do, for example, x squared plus 6x plus, I don't know, 7. My bad. Essentially, if you had a quadratic that looks like this, you would be completing the square. Okay, so this, if you would complete the square of this would be minus 9 plus 7. This would be minus 2 if you completed the square on this. Okay, well, the minimum value of your completed square form, this is very, very quick to do. The minimum value is just your y coordinate. It's going to be minus 2. So that means all of your stuff has to be bigger than 3 over minus 2. Okay, don't fuss about this. It's only 1-2 marks. It's not worth it. Okay, get the compound functions done. Get the inverse functions done. That's the majority of the marks. We're going to move on because I can't, otherwise we're going to be here for ages. Alan, I know you see that on TikTok. I will come back to it at the end. Okay. Why am I completing this square? It's because we're trying to work out the minimum or maximum point, Shanaz. That is why. That's the whole essence of this. Okay. Parametrics. I know we're jumping to a big topic. You want to do more function stuff. How's you more confused? Alright, guys. Lock in. Stop texting in chat. Stop texting in chat. Yeah. Lock in. Lock in. Okay. We're going to do parametrics. X over Y. That's not too bad. Give a go on this question. We'll do functions. Multiple functions. Some of you understand it, some of you don't. So, I don't know if that works. Yeah, thanks, Lexi. Appreciate it. Functions is not a hard. It's a difficult topic. It's not easy. Is it 2t? It might be 2t. X over y. That's going to be t over 4 over t cubed. That is t. Okay. Hence, show all the points on C satisfy the equation. What am I eating? It's chocolate squares. And I had a lesson in the morning for like 2 hours, so I can't lie. Yeah, man. Okay. Chances are as well. Oh, how did I get part A? Okay, essentially I did t over 4 over 2, that's your x, divided by your y. KFC, keep, change, flip. Gonna flip it around. 2t plus 1 over t cubed. That's the same thing as t over 4 over t cubed, which is just t. I would not recommend textbook at this stage. Do not look at textbook at this stage. Okay, it's too late. The questions, they're like, they would differ a lot in terms of exam questions. I would avoid it. Yeah, man. Keep, flip, change. Okay, part B. Hence, show all the points on C satisfy the equation. If you're in the exam, your part A will link with your part B in some way. Okay. Remember, you're not doing part A for no reason. I mean, in this case, you might be, but chances are, most of the time, you will be linking it in some way. What am I slapping in? T. Some sections of the live stream I felt did not go as smoothly as I planned them to. So I'm just re-recording this section again, just to make it a bit more clear. So let's do this. I can show you that the next live stream that I've planned is going to be a lot more streamlined. So let's do this. I think I left in the video already how we ended up with x is equal to yt. We just do x divided by y here. And then for part B here, what we can do essentially is we can have our x equation, which is x is equal to t to the 4 over 2t plus 1. And I'm just going to substitute in this into here. So I essentially have x is equal to x over y to the power of 4 over 2 x over y plus 1. This leaves me with the following. X is equal to x to the power of 4 over y to the power of 4, all divided by 2x over y plus 1. So I've just expanded that out. I'm going to make this a common denominator. So this ends up with x is equal to x to the power of 4 over y to the power of 4, all divided by 2x plus y over y. So I've just combined it as a common denominator. Now you can see here that we have, well, this is to the power of 4, y to the power of 4. And at the moment this is just a y. So I'm just going to treat this as it's kind of almost a fraction. And I know having a fraction inside a fraction is it's not nice, but we'll get rid of that in a second. I'm going to do some common denominator work. So I'm going to times the numerator and the denominator by y cubed, so I get y to the power of 4, and you'll see why in a second. Okay, and then from this, what I'm going to do is x is equal to x to the power of 4 over y to the power of 4, all divided by, now I've times this denominator by y cubed, so this becomes, a fraction by y cubed on the numerator and denominator. So this becomes 2xy cubed plus y to the power of 4, all divided by y to the power of 4. So you can see I have two fractions. Now if I'm dividing a fraction by a fraction, that's essentially the same thing as this. KFC, keep, change, flip. So this is going to turn into a times. This is going to be y to the 4 in the numerator. This is going to go to the denominator, like so. And remember, this is still x equals. I'm going to move this section down. And this is going to become x is equal to x to the 4 all over 2xy cubed plus y to the power of 4. And you can see that this is actually getting very, very similar to what we had in the question. And then I'm just going to divide by x. Reason being is it'll just make it a lot more easier in terms of the question asking for x cubed. So I'm going to divide everything by x. This gives me 1 is equal to x cubed over 2xy cubed plus y to the power of 4. So that means that 2xy cubed plus y to the power of 4 is equal to x cubed. So that means that x cubed minus 2xy cubed minus y to the power of 4 is equal to 0. Okay. Alright, we're going to skip that. We'll come back to parametrics later on. I'll find, well, I've got some more. Honestly, I've picked it, but honestly, I have not really looked at the difficulty of the question, so this might be a bit harder than it looks. But yeah, let's wing it, bro. Let's wing it. You're not cooked, bro. It's not coming up. Trust me, it's not coming up. Okay. Guys, my first live, bro. Give me some slack. Alright. Part A. 1 over 4x plus 1 to the power of half. These type of questions, they're not too bad. You can go about using a substitution way. But don't do u sub. U sub. Allow sub, bro. Allow sub. Allow the sub, bro. Don't do no sub. This is what you're going to do, man. You're going to convert this into an index form. You're going to do the chain rule. Yes, reverse chain rule. Okay? So we're going to be essentially integrating this. If we were to differentiate, let's think about what happens in terms of the differentiation. Okay, if you were to do some differentiation, 4x plus 1, let's do, yeah, actually no, let's stick with this. I'm going to keep this as an example. Okay, if I was to add, if I was to do my normal integration, I'm normally going to add 1 to the power, right? So I'm going to do 4x plus 1 to the power of a half. If I was to differentiate this, just to check if I was to differentiate this function, well, obviously my power decreases by 1, right? But it's chain rule. We have to times it by the inside differentiation, which is 4. However, we can see the coefficient here is 1. So what do we have to do? What do we have to do to this function here to make sure we don't have this 4? What do we multiply by? Divide by 4. Perfect. We divide by 4. We're not going to divide by 2. We're going to divide by 4. Okay? So we're going to times this by a quarter. Oh yes, you're right. You're absolutely right. I forgot to divide the power. You're right. You're right. Absolutely right. So that would be a 2 in front. That would be a 2 in front. Would that be a 2 in front? A half. Yep. You're right. Absolutely right. Absolutely right, guys. Silly mistake. Absolutely right. Absolutely right. Absolutely right. But you get the gist of it. Okay. I'm gonna give you another one, just like that. So the coefficient here would be a half. I'm gonna give another one, and you guys are gonna integrate that. And I can't forget the plus c. Integrate the following: 1 over square root of 6x plus 7. And then once you've done that, integrate square root of 2x over square root of 3x squared plus 9. Yep. We'll go back to the limits. Okay, if you want to use U substitution, you can. Use your U substitution. That's completely fine. I believe that's right, Tyra. Ethan, use your U substitution. Okay, if you're unsure, just do U equals 6x plus 7. Okay, if you think that's helpful, do that, and then do your du by dx. Okay, do it like that. So this is going to be 1 over. I'm not going to do the substitution in this case. Okay, that's going to be the following. If I was to integrate this would go to a half. This would differentiate to a half times by 6 times by 6x plus 7 to the power of negative a half. But I don't want 3 as a coefficient. I just want 1 as a coefficient. So what I'm going to times by, I'm going to times it by a third to get rid of that. Okay. Next one. Use your chain rule. The reason why I'm doing differentiation here is because I'm adding 1 to the power essentially, and then I'm checking what would that differentiate to. Okay, and then I'm just adjusting. Yeah, stop glazing me, Fred, bro. Stop glazing. Stop the glaze. Okay, I'm gonna do a U substitution version here. Okay, just for the guys that might be struggling with the reverse chain rule. So this is what our U substitution would look like. U is equal to 3x squared plus 9. Okay, Ethan, watch. Look. Okay, write this down. Write this integral down, and then start with a u substitution. U equals 3x squared plus 9. And then I'm going to differentiate this, so this becomes du over dx, which ends up with, and this should actually have dx in our original question. Du over dx is just going to equal to 6x. Yeah, of course, Cindy, of course. And then I'm going to take this dx and I'm going to rearrange. Well, du is equal to 6x. Sorry, du over 6x is equal to dx. So that means that my original function is going to be integral of 2x over square root of u du over 6x. Oh, look, the x cancels out. Boom, boom. And then this just becomes 2 over 6. I'm just going to write that. I'm going to leave it like that, actually. Let's leave it like that for now. And that becomes 1/3 1 over square root u du. Integrate this. This becomes 1/3 u to the minus a half. If you're going to integrate that, that becomes a half minus 2. This should be at the beginning. Minus 2. And that should still be an integral. Oops. Okay. And then that goes to the following. Minus 2 over 3 u to the half, which is actually 3x squared plus 9. Okay? Do you see this? Does this make sense? Do it like this if you're unsure. Isn't the 2 positive? Why is the 2 not the 2 is not positive because of this negative a half, that's why. Am I sure it's negative? Let me check. I might be wrong. I might be wrong. One sec. U to the half. Oh yeah, sorry guys. Yeah, my bad. It is 2. It's 2. Yep. Sorry guys. No, it's positive. You're right. It's positive. It's positive. The reason why I'm doing u substitution is if you don't understand reverse chain rule. Okay, reverse chain rule. Let's do it the other way. In my opinion, it's a lot quicker and it will save you a lot of time. So I'm going to write this as the integral of 2x. I'm going to bring this up, so this becomes 3x squared plus 9 to the minus a half. First thing to spot is, what does this even differentiate to? If this differentiates to something with an x, you're fine. If it doesn't, yeah, there's a problem. Okay? But usually it will. Hopefully it does. And then that will allow you to do your reverse chain rule. So this is what we're going to make an assumption of. Where does the 2u come from? That comes from the integrating u to the minus a half, Ethan. So what I mean by that with an x, we'll see. Okay, I'll show you. So let's make an assumption that our key value is 3x squared plus 9. And the reason why we make that assumption is just the more complicated looking one. Okay, the more complicated looking one. Listen, bro. Let me cook. We're making our assumption with the more complicated looking one and with the power. Okay, that's our assumption, guy. That's the one that's going to be getting differentiated. Okay, so what I'm going to do, I'm going to add 1 to this power, because when you integrate, you just add 1 to the power. Yes, James. Yes, I would. Okay, I'm going to add 1 to the power just as you integrate. However, opposite of integration is differentiation. This is not the correct integration yet. So I'm going to check, when you differentiate this function, does this differentiate back into this? Let's have a look. Well, if I differentiate this using some chain rule, my power goes to the side, half, times by, now this internal differentiation, you guys told me it differentiates to 6x. That's a good thing. We have a 6x, this x here matches this x here. If it was x squared, it was a problem. If it was x cubed, it would have been a problem. Okay, but since it's x on both ends, it matches. It's good. Then I'm gonna keep the inside brackets the same, and then just decrease 1 from the power. This is our chain rule. This is just chain rule. Okay, and this differentiates to 3x. I've just simplified this like so. Now, you can see this doesn't match. This is 2x and this is 3x. So we need to make a slight adjustment to our assumption that we made. So how do we go from 3x to 2x? Well, we just times by 3 over 2. Sorry, 2 over 3. So this will be times by 2 over 3. This will be times over 2 over 3. And this will be our original, or final integral, plus c. Okay. And you can see here, this does match. Sorry for the mistake I made earlier, guys. But yeah, it does match. Okay. Whatever method is easier for you, do so. But accuracy is key. I'm not gonna bother over the limits. Okay, limits is, I'm not gonna waste time with that because in my opinion it's just substituting the numbers in and you get an answer. Okay, I'm not gonna fuss with the limits. Okay, you can use substitution for a lot of integrals, Sophie. Not every single integral. For a lot of integrals. Some integrals you just can't. If you had, for example, this integral here. This is a bit of further maths actually. If you make this a 3x squared, this is not an integral you will see in A-level maths. This becomes a further maths question, and this becomes, I believe, it's an arc sine of just testing root 3x over 1/3, I believe. 3, I believe it's that, and then something like that. It's something close to that. It's not exactly right, but because of that, before that of that x squared, because 3x squared doesn't differentiate to an x squared, that becomes an issue. Okay, so you cannot use your substitution, your reverse chain rule on this. Okay, a lot of the stuff you would be able to, yes, BMT, you would be in a trig sub, yes, we would. Okay, but that's not A level, so do not worry about that. Okay, let's go back up. Differentiating trig. Now, actually, I'm gonna focus on. Actually, let's differentiate this first. Sorry, integrate this first. Let's integrate this first, and then I'm gonna show you this one here, because this question came up in the 2024 paper, or something very similar to this actually, and I'll show you how to do that. Okay. Okay, good, easy, right? Reverse chain rule, very nice. Okay. Cos integrates to sine. Sine 3x will differentiate into 3 cos 3x. We don't want 3 cos 3x, so we're just going to times by 1/3. Easy peasy. Very good. Okay. Now, this function here. If you ever see sine squared, do not do reverse. Do not do reverse chain rule with this. Do not add to the power. Do not do any of that. Okay? And this also applies to cos squared as well, by the way. Okay? You're going to be using, exactly, Tara. You're going to exactly be using your double angle formula. So cos 2x is going to equal to 1 minus 2 sine squared x. If you haven't learned this, you don't have to, but it's better to, I guess. If you've learned this formula, that also works, but then just convert that into 1 minus 2 sine squared x. Okay. There is no other method for this. Actually, there is one more method. It's further pure. Further pure. I haven't done further pure modules, so I couldn't tell you, to be honest. Actually, no, it's Maclaurin series. It is called pure. You could do it technically. Anyways, though, yeah, you're gonna be using this formula here. Gonna rearrange for sine squared x. That gets you 1 minus cos 2x all over 2. It's gonna equal to sine squared x. Is it not FP1? Alright, fair. And then you just essentially integrate. So you have the integral of a half minus a half cos 2x dx, and now this is a lot more doable. Is it? Yes, Taylor. Yes, Taylor series. Yeah, it's not Maclaurin. It's Maclaurin something else. Yeah, man. Maclaurin's is linked. The Taylor series and Maclaurin's. I can't remember what Maclaurin's are. I might be waffling here because I've forgotten a lot of my further. I think it is Taylor series. Maclaurin's something else. Okay. Anyways, a half goes to a half x. Very nice. Cos 2x integrates to sine, but we know that sine 2x differentiates to cos 2x. We don't want that. So what we're going to do, we're going to times it by half. So that becomes a quarter. Plus c. Okay. Alright. Using that logic, I want you to integrate this. No, we cannot use reverse chain rule. We cannot do reverse chain rule on this. You're afraid? Is that Rico? Is that Rico, man? Use the same logic with this and get me an expression for this, guys. Yes, plutonium. You're going to be using... Well, I would actually expand this out first. And then you're going to be using your cos 2x identity. Okay. I'm not going to bother with limits today. But yeah. You're learning, Ethan, you're learning. Yeah, guys, if you want to go get some snacks, just go get some snacks as well, man. We're going to probably have a little bit of a break in a bit. You guys on TikTok, just join my live from YouTube on my bio. Just join in. Guys, don't violate Ethan, man. Ethan, you're going to pass. You're going to cook. You're going to cook. Trust me, you're going to cook. You need to believe. You need to you need to believe in yourself. That's the first step. Yes, my guy. Precious for tires. Yo, guys. After you do your A levels, yeah, go get your driving license. Get that. I know you guys haven't passed your theory either. I know a lot of you haven't. Get that driving license. Yes, Tony. We're gonna do double angle formula and then we're gonna substitute in. Okay. Yo, Rohama, I'm waiting for you guys to do it. I'm waiting for someone to give me an answer. I'm not doing it yet. I've given you the sine squared up here. Thank you, Rico, my guy. I will check that. If you want to confirm if Fred got that right. Oh, come on, 49 out of 50. Double angle formula is Lexi is kind of, you get a formula that says cos A plus B, and you can kind of derive it from there. But I would advise that you learn your sine 2x and your cos 2x. I will write it on screen. Sine 2x is the same thing as 2 sine x cos x, because if you are able to spot these identities, it just makes it a lot more easier. It just saves you a lot more time, to be honest. And this is, you have 3 identities for cos 2x, but I'm just going to write one of them because you can derive the other 2 from that. Okay. Okay. Let's double check this. Okay. Let's double check this. So we're gonna have the integral of 4 cos squared x minus 4 cos x sine x. I'm actually gonna put sine x cos x. Looks nicer. Sine x cos x, and minus the integral of sine squared x. I'm just gonna double check. Sorry, that should be plus. That should be a plus. Just gonna double check this. 2 times cos x sine x, and that's times by 2. Yep. Okay, so we're gonna have the integral of that. How do we derive the other ones? What do you mean derive the other ones? You guys wrote the question out wrong? Oh. Alright, have a go again. Okay. Now we're going to use our identities. We know that cos squared x is equal to 1 minus 2. Oops, that's wrong. Cos 2x is equal to 1 minus 2 sine squared x. That's one of our identities. The other identity is cos 2x is equal to 2 cos squared x minus 1. And this identity here is actually very special, because this is actually your sine 2x identity. So being able to spot these helps you. Honestly, it'll just save you time. So sine 2x is equal to, I've already written it up there actually. Okay. I'm gonna quickly rearrange these. If you're unsure about rearranging, just check up on your rearranging, I guess. So this is gonna become 1 that'll be plus 1 cos 2x plus 1. So that's gonna be 2 cos 2x plus 2 for that part there. This middle section here is gonna be minus 2 sine 2x. Great for the guys in chat. And then this end part here is just gonna be cos 1 minus a half cos 2x dx. I'm going to simplify this a bit more. You figured it out, Ethan. My guy. And then we're going to simplify this a bit more. 2 minus a half, that's going to be 1.5. So that's going to be 3 over 2 cos 2x. That's going to be 5 over 2 here. And that's going to be my integral. That should be your integral so far. Okay. Now this should be able to just integrate quite nicely. That goes to sine 2x. Sine 2x obviously differentiates to 2. Sine 2 is 2 cos 2x. We don't want that. That's wrong. We want 3 over 2. So what am I going to do to go from 2 to 3 over 2? I'm going to times by 3 over 4. That's a horrendous maths, guys. Yeah, 3 over 4. Yeah, 3 over 4. So we have 3 over 4 to sine 2x. This goes to plus cos 2x plus 5 over 2x. Step 2 is reverse chain rule, yes. Step 2 is reverse chain rule. But if you're unsure about plus C. Oops, sorry guys. But if you're unsure about the reverse chain rule, you can use your U substitution. Yes, Fred. I'm not going to bother with this one. Let's look at some modeling. I have not. This is the first time I'm seeing this question. This is Harry. Thank you in the chat. If you want to join the YouTube link, I'm replying over there. But that's my sine 2x identity. That's how I got that to sine 2x. Okay, have a read. This is the first time I'm seeing this question. Honestly, all of these questions, first time I'm doing them with you guys. Okay. Do I do positive cos? Yeah, positive cos. Cos differentiates to minus sine. Sine, cos, minus sine, minus cos. Minus sine integrates to cos. Where did the plus 2 come from? What do you mean where? Using the identity here. Using this identity. Okay, I've just rearranged for cos 2x, cos squared x. And we're gonna have a break. We're gonna have a break in 10 minutes. Second line 10 minutes, Avi, 10 minutes, 10 minutes. This question 10 here. Okay. Have a read if you want to have a break. You know what? Have a 10-minute break if you want to start this question. That also works. Vectors, we can do a bit of vectors. I didn't have anything planned for vectors, but I can pull something up. Cool. 1 second. Rico sent me some stuff. Alright. You guys, do you want a break? Let's do a break, man. Let's do a break. Ryan, just maths today, man. Just maths today. I'm actually planning on going from doing a bit of chem, maybe not today, but L cubes, double angle formula. So I rearranged for cos squared x, and then times that by 2, essentially. Yeah, yo, send it. Zoom in. Is it too small? There we go. Is that calm? There we go. There we go. Yeah, then I need some writing space as well afterwards. You did this question? Yeah, I think this is from Matters Maths. Should you carry on doing some papers, or I'd say some topics are like they're low marks. So if there's anything like functions and stuff, I would say it's not worth putting a lot of time into. You have about a week before your next exam, or before maths exam, anyways. So yeah, I'd say look into papers. I think if you're finding papers easy, then look at topics as well. Matters Maths, it's not exactly similar to OCR. OCR spec is a bit weird. Some of the questions are okay, some of the questions they make really difficult. I think OCR I think it's pretty tricky. But I think Matters Maths, a lot of his papers, he makes it hard on purpose. You do either 20 past papers. You've got 20 past papers left. What do I recommend for OCR and MEI? I'd advise you look at some Cambridge papers, Justin. Because I think MEI is international, right? I'm assuming. So looking at Cambridge papers are really, really good for that. Potentially international papers, but I think international papers, they get really repetitive. They're good, they can get repetitive. Matters Maths is also really good. I'm gonna read the question. I haven't even read the question yet. We're having a little break for like 5-10 minutes. Yeah, 100% right. Look at Edexcel. 5-minute break. Start again at 5:20. Yeah, Sophia, yes, on YouTube, just join in. Where can you find practice papers with mark schemes? On Physics and Maths Tutors, good. Oh, you guys want to know, what's it called? Predictions. I think it's dropping. Next week, I mean. It's harder, bro. Paper's going to be hard. I'm saying for an A-star, last year, it was 82%, I think. 260, it was 260, I think. 260 was 87. I think it's dropping to like 8%. OCR Chem, I think it's dropping to 87. 86, 87. OCR Chem's always high anyways. This is Edexcel predictions, right? OCR Chem, OCR A Chem. Yep. And A, I think if you just minus 10% from that, that's like your each grade boundary, like minus 10%. So I think they're going to be high, just because I think students are getting smarter over the years. Teaching's getting better. There's more resources. Geometry. I'm planning on doing geometry later on. Geometry is going to be on there, in my opinion, in some way or form. Last year there was a geometric question. I think I haven't looked at the examiner comments or anything, just because I don't have access to them. But I know that a lot of people, they struggled. Like in my school, very, very few people got them right. Just because I think the only people that got them right were people who were maybe applying to like a maths degree. Maybe if they did the teamwork or did the step or anything like that. That's probably the only reason why they might have got that geometric question right. If you are wondering what it looks like, it looks something like this. You might have seen it. It is on my TikTok. But you might have seen that. It looks something like that. Mechanics and stats, 100% going to be harder. Mechanics and stats were piss easy in 2024 paper. Paper 1 was quite light, to be honest. Yes, I did have to do econ entrance exam for econ. I did the teamwork this year. This year? Yeah, it was this year. It was alright, BMZ. It was alright. Teamwork was interesting. You know what it is? I found it quite good. I found it better than the other years. What type of modelling is this? It is some sort of modelling. We'll start again in 3 minutes. This is for any exam board. Still water. Ryan, I'm doing a LSE Econ now. which is yeah. Inshallah, man. No, but yeah. No, I've been it was unconditional, so I've already got my achieved grades. Is this live recorded? Yes, it is. Yes, it is. I will be uploading it. Could I write each cos double angle? Yes, of course. There are three. There's L cubes. There's 3 different types for your cos 2x because they derive from each other essentially. 1 second. Let me make this thinner. So if you want to get the angles down, so this would be cos 2x is equal to cos squared x minus sine squared x. That's one of them, and from this you can derive it to make this, and it's also this. And then for your sine 2x, it's just 1. This is for the guys on TikTok. But yeah, is there going to be a stats and mechanics specific course? Potentially. I will try my best. I'm planning on making a chemistry one. Tan 2x has never come up. I can't lie, it's never coming up, bro. Tan ain't coming up, man. You guys can't see the sine one. The guys on YouTube, I'll move the sine one here. How do I derive them? Essentially, you use your cos squared x plus sine squared x equals 1 for this. Okay, and then you just substitute this kind of identities into here, and you'll be able to rearrange. I can't. I'm telling you, tan's not coming up. T equals 45. I don't know, bro. I don't know. I haven't got the masking for this. I should probably put up the masking, but I haven't got masking. What was the pinging noise like before? I actually don't know what the pinging noise mean. What does it mean? I can't even check it. Alert box. Skip. Done. What does it mean? You want to do the question? 1 more minute. 1 more minute. And then we'll start again. Let me check Discord. Alright, you know what? We'll do some more functions in a bit. It might come up. I think sine and cos could come up. I think first principles is a type of topic. It's alright. I think it's kind of ignored. Geometric proving. To be fair, proving geometric I haven't really seen come up much. I don't think it will come up really. But geometric and arithmetic are always there. Alright, you know what? Let's start with this question. And in a bit, 1 second, let me move this to the other screen. I don't even know what paper this is from, I'm going to be honest, bro. Let's see how this goes. This could be a very interesting question. Okay. Alright. We got a spherical balloon. It's the first thing that comes in my mind. Sphere. The first thing I'm going to write is the volume of a sphere, and it has already given it to us. 4/3 pi r cubed. And just by habit, what I normally do is just differentiate this anyways. So this becomes dv over dr, which is going to be 4 pi r squared. Okay, just by habit. This may come in handy, it might not. No, Shanaz, you might need the sphere. You will need the sphere one actually. Chances are they might give it to you, but I've seen a question where they haven't. So a sphere, I would learn the sphere. The surface area you're not expected to know. They'll give you that 100%. The volume of a sphere is probably one I'd learn. And cone potentially I would learn as well. A cone. Okay, so this is your cone. So cone, this is the volume of a cone, and the volume of a sphere I'd learn. There's 2. Cylinder. Yes, you're supposed to know about a cylinder. They expect you to know about a cylinder in GCSE as well. The surface area of a cylinder. If you want to know how to work out surface area of a cylinder, I think they mean surface area. I think they mean in terms of surface area of a cylinder. Obviously, you have your 2 circles on the top and bottom. Okay, so that's just 2 pi r squared. Okay, but we also have this kind of curved region. Well, essentially, it's a rectangle that's kind of curved around your circles. So you have you have your height here. That's your height, and then you have this region which is kind of curved around. Now, what is that? That's exactly. Yeah, Ethan, chill out. It's a valid question. This would be your pi diameter. This is your circumference of the circle, so we can call that pi diameter h, or 2 pi r h, which is the same thing. Okay, that's your surface area of a cylinder, and you're expected to be able to work that out. They will not give you that. Okay, so that's something that you may need to know. We're doing this question now, Tara. We were just going a bit off topic on what you need to know, but yeah. All right, let's start with part A. I'm going to keep on reading. It's filled with a special type of gas floating at a very high altitude. Okay, gas started escaping from its valve, so that the rate is surface area. Okay, surface area is decreasing. It's directly proportional to the square of the surface area at that time. So the rate of the surface area, so that's dt over, so dA over dt. Okay, is directly proportional to the square of the surface area. So I can make an expression with this. dA over dt is equal to Ka squared. Alright, let's see what we can do with this. By relating the volume, the surface area, and the radius of the weather balloon, find dV over dt. Well, dV over dt, do we not use t as well? Yeah, it should be minus k. Yeah, you're right. That works. What do you mean? Do we not use t as well? Yeah, you guys are right. It should be minus k. Yeah. Let v be the volume of the balloon. T hours since v equals 1,000. No idea what that means. I'm going to be honest. Let v meters cubed be the volume of the balloon. T hours since v equals 1,000. Okay, so the starting point is 1,000. I'm assuming like, I don't know, meters cubed, centimeters cubed. Oh, it's meters cubed. Okay, that's the starting point. Okay, dV over dt. I'm gonna make an expression for this. We have our area. Well, we've been given actually a surface area formula as well. So I'm gonna differentiate this. So A is equal to 4 pi r squared. dA over dr is equal to 8 pi r. And essentially, you having an expression like this and just differentiating it, you are making formulas and you're getting marks by doing these formulas. You're good? Yeah? I'm assuming you guys... Yeah, gas is escaping it. Okay, so now we made some formulas and let's try to essentially... Can you say what everything... It says... Yes. Okay, let's continue on. Wait, what? Any questions so far? How I have ended up with these formulas? Where did I get the dH over dt? This is dA. This dA over dt, essentially I've ended up with the sentence they've given us, that the rate at which the surface area is decreasing, so the rate, which is dA over dt, okay, is directly proportional to the square of the surface area at that time. Do you guys not like the pen? Broski, that's my handwriting, bro. Don't violate my handwriting. Let me pick the pen thinner. One sec. There we go. Alright. Don't violate, bro. Alright. That's from the paragraph they've given us, and then from there I've essentially made this expression. The way the pen writes, that's my handwriting, bro. That's my hand. Look, it's a pen. That's dope. Okay. Anyways, we want dV over dt. So dV over dt, I'm gonna have dV over dA times by dA over dt. The reason why I've chosen dA is because we've already had A in our expression, and this is the only way we can make dV over dt, by cancelling out this way. Okay. Well, we have dA over dt here. Check. Do we have dV over dA? We don't. Not right now. We don't. By relating the volume. What's the question asking us? Is it a show that? Oh yeah, it's a show that. The radius of the balloon is that. we might have to use dr potentially. We might have to potentially use dr, and that's why it's a 4 marker. So we might have to do another sort of thing. Okay, let's continue with this. Essentially, what's going on here is we need to make an expression. Oops. We need to make an expression for dv over dA. We haven't got dv over dA. So what we're going to do is we're going to use dv over dr to make dv over dA. Let's make another formula. dv over dA is equal to dv over dr times by dr over dt. Do we have oops, that's wrong. dr over dA. Do we have dv over dr? We do, which is 4 pi r squared. Cool. Do we have dr over dA? We have dA over dr, so we can flip that around. That becomes 1 over 8 pi r. So then, we're going to expand this out, or just simplify it. So this becomes 1 over 2 dv over dA. It's going to equal to 1 over 2r. What the heck is going on in the chat, bro? Let me read this, man. What you guys talking about, bro? Focus, lock in. Yeah, is R on the top. That's my bad. Guys, my maths is not that bad. Yeah, R on the top. Now I left a section in the video. However, you can see again there was a lot of kind of distraction in the chat. So I'm going to kind of redo this part of the question. Well, we've been given a section in the paragraph here where it says that the surface area is decreasing, which is directly proportional to the surface area. If you watch this part of the video already, great. That means if I write it like this, dA over dt, which is the rate, I should probably highlight this as well, the rate of the surface area is decreasing, is directly proportional to the square of the surface area at the time. So I'm going to write this as dA over dt is equal to minus ka squared. Now if you have formulas as well, you should take them and also differentiate them, because they will help you out. You've been given volume, so that means that dv over dr is the same thing as 4 pi r, that should be cubed, so this should be 4 pi r squared. And we can do the same thing with surface area. A is equal to 4 pi r squared, so that means that dA over dr is equal to 8 pi r. Now the question is asking us to work out what dv over dt is. dv over dt, well, we don't have it, but we can make it. And the first variable that comes to mind is that we can use dv over something times by something over dt. Well, the first variable that comes to mind is dA, right? We could use dr, but at the moment, you can see that we don't really have dr over dt or anything like that. But we do have dA over dt, so we can work with that. Okay. So we want to work out dv over dt. Do we have dv over dA? We do not, but we do have dA over dt, which is here. Okay, so before we continue on, why not, let's make another expression for dv over dA, where we get the following. dv over dA is equal to dv over, well, the other variable which we haven't used is dr at the moment, so I'm just going to use r, and this is going to be dr over dA. Okay, well, we have dr over dA in this form. We're just going to flip it around, and we have dv over dr, which is here. This is the same thing as 4 pi r squared times by 1 over 8 pi r. And if you simplify this, this ends up with r over 2. And I'm going to go more to the right here, so we have more space. Oops. Then, what we're going to do is, well, we worked out what dv over dA is now, and we're just going to plug this back into the value here. So we have the following. dv over dt is equal to dv over dA, which is r over 2, times by dA over dt, which we worked out right at the beginning from the paragraph, ka squared, and it's equal to minus kr over 2 a squared. A squared we know would be this, minus kr over 2, 4 pi r squared all squared, which is going to be minus kr times by 16 pi squared r to the power of 4 all over 2, which is the same thing as minus 8 pi squared r to the power of 5. Okay, and the question's asking us, well, we need to write this in terms of, well, v. We know that volume is given as the following, volume is given to us as 4 over 3 pi r cubed. If we put the power as v to the 5 over 3, what happens is, well, all of this will get to the power of 3. It doesn't really matter. I'm going to put this as dot dot dot. Okay, but our r variable here, you can see whenever we index it to the 5 over 3, this will just become r to the power of 5 because of your index loss. You can see these 3 cancel out and we're left with 5. Okay, this bit at the beginning, it doesn't really matter because the question is asking you leave it in terms of k. It's a constant. It doesn't matter. So this part here, this is a constant. This is a constant. That means that this must just be minus k v to the 5 over 3. This section does not matter. Circle's gonna come in this year, I'm telling you. Have you already done it? Have you? That's good then. I mean, that's a good point. That's a good point. But do you guys know how to do the part B? The part B is the main thing, because you know what it is. A lot of students do, it's a good thing to be fair. Having and I'll take the 3 minus 7 from you guys. Having the idea of discriminant in circles, I think it's good. Alright, let's go through it. In circles, when you're unsure, draw yourself a diagram. Okay, draw yourself a diagram. Minus 6, minus 8 is probably around here somewhere. What's the first coordinate? 3 minus 7 is probably here somewhere. I'm going to draw a circle here, and I'm going to draw a circle here. Like so. Cold. Okay. Now this is center minus 6, minus 8. This is center, what was it, center 3 minus 7. Yeah? Calm? Now we want to find out when circle 1 and circle 2, or you can just keep circle 1 constant, when circle 1 and circle 2 intersect between 2 different points. So that's going to be at the verge, that's going to be the verge of here, and as it gets bigger and bigger and bigger, our second point, it's going to be around here. That's our limit. That's our first limit, that's our second limit. Oops. And that's our first limit. Okay, so your region of having 2 intersections is between here and here. Does that make sense? So essentially we're finding the range of k of where that's allowed. Yeah, there you go, Imran. Okay. Alright, let's start with this. I'm going to move this circle down because it's a bit... There we go. Alright. First thing that comes to mind when it says ranges of k is discriminant. Okay, and you can do this with discriminant. It's completely valid. You'll end up with the quartic though, and you end up with like 2 pages of working. But yeah, the equation on the line from the 2 centers. You don't have to do equation. You have to do equation of the line, but you can just work in terms of geometry. Let's find out the, well, we know the radius. We know the radius of 3 minus 7 is 5, right? We know this radius. So the only one that's changing, the radius that's changing, is this one here. So this radius here is k. Okay? Now, that's essentially what we're trying to find out. Well, let's start off with finding out what's the actual distance between these 2 points. What's the distance between the 2 points? And we can work that out with some what's the word? Pythagoras. Good, it is k plus 5 and it is root 82. Good. With Pythagoras, between the 2 points, it's just going to be root 82. So that's going to be minus 8 minus 7 all squared. Plus minus 6 minus 3 all squared. Square root that, and that should give us root 82. Let me check if I've done that correctly. Yep, and that gives us root 82. Okay, so that means that this whole distance, if this whole distance here is root 82, can you express k in that sort of form? What would this distance become then? If the whole distance is root 82, we know the radius is 5, what would this distance become? Perfect. Root 82, take away 5. That's when it's intersecting at that first point. Okay, that's one of our answers. Our second answer, well, not answer, limit, I should really say, is when our circle is really big and we have this value here. Exactly. We're going to add, it's not root 82 plus 10, we're going to add another 5 here. Yes, Destiny, it's root 82 plus 5. Okay, because you have this root 82 here, and we're adding on another 5. Okay, so your two values, the reason why I made the circle big is because that's our second region. Our first region, our first limit is here. Our second limit is here. Okay, that's your two distinct points between here and here. Okay, so our first value of k, I'm going to write down, we worked out as root 82. I'm going to put minus 5 plus root 82. Our second one was 5 plus root 82. But obviously these are distinct values. And we want the region which is in between. So that means your k has to be in between these two values. So your final answer is going to be minus 5 plus root 82 is less than k is less than 5 plus root 82. That will be your final answer. Okay. The reason why it's not just like this is because it could be here, it could be here, it could be here, it could be here. We don't know. Okay. I'm gonna get it up on Desmos real quick. I'll make a quick and yeah, it should be in set notation. Yeah, you're right, absolutely right. K is real such that, and you can actually just put a line even, you don't even need all the blah blah blah. You can actually just do this. K colon that's actually plenty, that's enough. But you should really just put real like that. That's probably a better way of doing it. And that's your set notation. Let me get it up in terms of Desmos so you can see kind of what's happening visually, because I know I've drawn it here. X plus 6, I'm going to show you what I'm doing as well on screen. X plus 6 all squared plus y minus 8 it was, I think. Y minus 8, y plus 8 actually. Y plus 8 all squared is equal to k. And we have a slider of k, and you can see this is our circle down here. And then what was our other circle? 3 minus 7, I believe. Correct me if I'm wrong, please. Plus y plus 7 all squared is equal to 25. Okay, and this is essentially what's kind of going on here. You can see this will be our first limit. Okay, and then our second limit, it's even bigger actually. I'm going to put this as 500. Our second limit is here. So essentially it's asking you what's the range between our first distinct point and our second distinct point. And essentially that's what we worked out. Okay, so it's not just that, it's the whole range. Does that make sense? Because if the circle's too big, look, there's no intersections here. Yeah, you want to see the set notation again? Your set notation should just look like that. Okay, set notation, you just say k is real with a bit of squiggly brackets, and just put a line like that. Yes, I would say Fred. I would say in my opinion that is probably the hardest. Why is it minus 5 plus root 82? Good question, Julia. It's because if we look at our first region again, you look at our first region again, you can see that if the distance between the 2 points is root 82, let me rub this out. If the distance between the 2 points is root 82, this point is 5. This makes this area root 82 minus 5, which is the same thing. I've just written it as minus 5 plus root 82 is the same thing. I think on circles they might chill a little bit more. But yeah, let's do some proof by contradiction. I think proof by contradiction will come up. Let's look at this question here. When you have algebra, honestly, a lot of it's to do with manipulation. A lot of it's to do with spotting as well, what's going on. I think it probably will. Fred, I agree. I really want to see the paper though when it comes out. I really want to see the paper. Okay, we have 9x over y. I'm just going to rewrite this. Y over x is bigger than or equal to 6. Don't assume. So it says proof by contradiction. So we're going to assume this instead. Assume that's opposite. 9x over y plus y over x is less than 6. That's your assumption. Yeah, there you go. Sorry, that was a typo, Tara. Yeah, less than 6, yeah. We're not going to do equal to, we're just going to do less than. Because that's the opposite. I appreciate it, Fred. My guy, man. Okay. Yeah, that is 1 mark. That is 1 mark. Next, what we're going to do is essentially expand out. Well, not expand out. I would probably do some common denominators, probably combine them somehow. Okay. And this ends up with 9x squared plus y squared over xy is less than 6. This is one note random. This is one note. So, if I multiply by xy, this becomes this. Let's keep going. If I move 6xy to all to one side. Yo, Shanaz, stop instigating, man. It's less than 0. What if xy was negative? It's a good question. We know that x and y are all positive, so it's alright. But in this case, if it was negative, to be honest, we probably wouldn't be able to multiply. That would probably give us some issues. And I think in the numerator we might have to. You could probably still do it in some way. I think it would just be a bit more complicated though. Okay. What is this? How can we show that this is not less than 0 to have a contradiction? And this is where I'd say separates the normal students and the upper students. Complete the square. We can complete the square on it. Amazing. Amazing. The guys who spotted this is 3x plus y all squared. Okay. Can a square number be less than 0? Sorry, minus y. It is minus y. Minus. My bad. Can a square number be less than 0? Cannot be less than 0. Therefore, contradiction. Boom, boom, boom. Smiley days. Smiley face. Happy days. Nice. It was a nice question. It was a nice 4 marks. Okay, let me see what else I got. You know what? Let me see what else I have. Geometry. I want to really look at geometry. I really want to look at this. I think in some way or form, I think geometry is going to pop up again. Yeah, Reed, man. You will, man. I think it's going to pop up in some way or form. This, by the way, is not the 2024 paper question. This is not 2024. It's not 2024. The numbers are different. It's not 2024. So, yeah. It's not a real question at all. Yeah, man. Can't be getting... Yeah. Can't be getting calls on my phone and be like, yo, where'd you get this question from? I made up this question. Just the numbers were like this automatically. Yes, yeah. In terms of it though, I think geometry will pop up in some way or form. Whether it's using radians, whether it's using some sort of like that sort of stuff. I think this stuff, this what's the word? Sections and sectors, I think a lot of students struggle with because it's unfamiliar to them. Just because when I did this question, first thing it reminded me was of equilateral triangles and GCSE. Okay, Shanaz, I can't lie, geometry doesn't pop up. It doesn't pop up in A level like this. They don't teach it. It's not really explicitly there much. I would say it's probably in the radians topic a bit, but yeah. Okay, we've got ABCOA, our arc here. We've got center O and diameter 8. So this diameter 8, we have a radius of 4. Okay, it says OB is also an arc of a circle, so that means we have a circle that's kind of like an imaginary circle back here. That means that if we have a center A, its radius is also 4, that means that AB is 4. O to B is also going to be 4. Why? It's because it's a radius. Okay. What is this type of triangle? It's an equilateral triangle. So we're able to do some work with this. I'm going to keep it visual for now before we do some actual maths. We need to think about what these areas are as well, because we can work out an area of an equilateral triangle quite easily. But we need to work out these little sections first. Year 2 vectors, there's that formula. There's you're talking about dot product. You're talking about dot product, Fred. Or sector area thing. Yeah, we work out the sector area. So to work out the mini section, we have area of sector, perfect kit. So area of sector minus the area of triangle, and that gives us the mini section here. And I think drawing this kind of that's dot product, Fred. To draw the angle. Yo, I'm actually like tap right now, bro. Wait. Let me take a bottle of water, bro. Draw out your stuff. Keep it visual as much as you can. I'm going to times this by 2 afterwards. Shush, man. Yeah, I'm going to times it by 2 afterwards. But let's work out the sector area first. Absolutely right, whoever said pi over 3. It is pi over 3. And I think keeping it in terms of radians is going to be helpful here. You can do it in degrees if you want, but we can just use our formula very, very nicely. So our sector area is going to be a half r squared theta. Your biggest problem in every paper is copying things wrong and adding instead of minusing. Luke, every single time you do your working out, check each line. Have you copied down the stuff correctly? Okay. Area equals a half r squared x minus sine x. You could do that. Sorry, essentially you just factorize it. AB sine, in this case, just radius. So you're absolutely right. Okay, so when you factorize it, you just end up with that. I mean, if you memorize that formula, then fair enough. But that's probably what you can work. This is how you can work this out in terms of working out the mini section. We know our theta is going to be pi over 3, and we know our radius is 4. Okay, so that means it's going to be 1/2 times by 4 squared times by pi over 3. This gives us 8 pi over 3 for the sector. Okay, 8 pi over 3. A half r squared sine theta, that's going to be a half times by 16 again. So that's 8 sine pi over 3. What's 8 sine pi over 3, anyone? 8 root 3 over 2? 4 root 3? So if I sub in theta is pi over 3 and radius is equal to 4, you should be able to just get that. Amazing. And that's equal to 1 section. Okay, that's equal to 1 section. we have two sections. We have two sections, so I'm just going to times this by 2. Two sections is going to be 16 pi over 3 minus 8 root 3. Okay? Yes, Loki. Next, we need to add the triangle. Well, we already worked out the triangle, which is 4 root 3. So I'm going to add 4 root 3 to this. So this gives me 16 pi over 3 minus 4 root 3. That's my area of this whole region here. Last step now, we're going to work out the area of the semicircle and just subtract that. Well, the semicircle area is just pi r squared over 2, which is in this case is going to be 8 pi. So our final formula, or final answer would be 8 pi minus all of this. Make sure you take care of your minuses. Okay? If you're subtracting a whole expression, put it into brackets. Okay? Because sometimes your minuses will turn into positives. And in this case you can see it does. Okay? 8 minus 16 over 3, I don't know what that gives me, but 8 over 3 pi plus 4 root 3. That will be a final answer. Okay? You need to treat your geometrical stuff like this. Make it visual. Think about how you can work out your small areas, because that will help you. Okay? If you ever see unusual shapes, think about sectors. Think about equilateral triangles, and these mini sections will honestly help you a lot. Okay? And if you want more questions like this, if you feel like you want more questions, I would recommend, honestly, go to GCSE. Go to GCSE Edexcel, paper 1s, and look right at the end of the questions. And I would recommend you try those. Okay? Because a lot of the questions, they use skill sets like this. In my opinion, you might have heard of the 3 circles question. Horror. Pretty sure everyone's heard of that. Okay. You essentially use the same idea for this as well. I think it was something like this, and you work out the area of these bits, I believe it was. But yeah. Okay. It uses the same idea. You had some areas, you work out the equilateral triangles, work out these mini sections, and then you subtract them off. It was very, very similar. Okay. Thank you for the notification. Still no idea what that does. I need to figure out what that is. We'll find out afterwards. Okay. Let's go back to some range and domain. Rico sent me a question. I think this is actually a good question to go along with. Okay. Is it a gift? Oh, fairs, man. Alright. No, it's not TikTok, it's from YouTube. It's YouTube. TikTok don't do that, I don't think. I don't think TikTok does that. Okay. Try this. I think it's a really, really good question, and I'll explain this. Yo, if you want to spam roses, that'd be nice, man. It's calm. Alright, start this. I'm gonna go take a piss. So I'll be back in like 2 minutes, 3 minutes. Be back. Yo! Can you wait one sec. Can you guys hear me? Can you hear me? Can you hear me now? What? That is weird. Wait, so you get wait. Before, could you hear me before? It said I've been muted this whole time, but you guys can hear me. It's muffled. Oh shit. Oh, okay. That's okay. Yo, that's why. Wait. Test. Yo. How about now? How about now? Is that better? You know what it is? I've been talking this whole time through my webcam mic. That's crazy. That is actually crazy. Oh, I'm an idiot. I have a whole mic right here. Yo, my bad. You guys should have told me. You guys should have told me. You guys, that's crazy, man. I'm gonna be back. I'm gonna be back in like 2 minutes. You guys. I'm playing in a football tournament this Sunday. I haven't touched the football since like year 11. Check that. That's crazy. Oh man, the man's locked in. It's gonna be crazy, man. Alright. Okay, party. What do you guys get as party? Let's scroll up. Yeah, yo, I just seen your message now. My bad. Let me get that up. Oops, my bad. Cool, thank you, Cindy. 2x plus 1 squared plus 8. Okay. I'm not going to bother with part C and part B, since the focus of this is the range. So essentially we have 21 over 2x plus 1 all squared plus 8. If we think about the maximum point of our quadratic, well, our maximum point is going to be just 8, right? So if I draw the graph of this quadratic, just the quadratic bit, it will look something like this. In this case, it's not the maximum point, it's the minimum point. So my minimum point of the quadratic is 8. Is it plus 7? Is it plus 7? Oh, okay. Someone said plus 8. Someone said plus 8, that's why. Okay, plus 7. Okay, cool. Minus 1, 7. That's our minimum point. So that means that no matter what we change to our x value to be, our most minimum point has to be 21 over 7. Or in this case, it might be the biggest, but we'll worry about that in a second. Is it quiet? Is it quiet? Is that better, Caitlin? Oh, it is 3. Oh, it is 3. Okay, we're working out the range right now. Shanaz, we're working out the range. This is the range. Okay, so my bad. Let me change that to 7. Okay. We're gonna sub in our x is equal to -1, or we can just look at our quadratic here, where we've got 21 over 7. That's our minimum point, or quote unquote maximum point of the quadratic. Okay, we're gonna just keep this as a key value. Okay, this is a key value. Okay, and obviously 21. Is it still quiet, Caitlin? Is it? Guys, am I quiet? Why do you quote on it? Is it equal to 3? Okay, alright, cool. Okay, Now, if we think about this graphically, obviously, if you don't have a calculator, it's a bit of irritating. But let's think about what happens to our denominator. So we found out the minimum value of the denominator. What's our maximum value of the denominator? Yo, Muhammad, bro, don't violate, bro. I'll mute you, man. I'll mute you. What's our maximum value of the denominator? We found out the minimum. Good. Thank you, Zach. Thank you, Zachariah. Our maximum value of denominator is going to be infinity. If it's infinity, that means our whole fraction is going to tend to 0. Because bigger the denominator, smaller the fraction. Do we agree? Bigger denominator, I'm going to put denom, equals smaller fraction. So that means our smallest value has to be 0 and our biggest value has to be 3. How can we write this? Less than g of x less than equal to. Does that mean function is continuous, or is that something... continuous functions... Oh, my light's turned off. Continuous functions is to do with iteration. I have to deal with this for a bit. Let me get my charger. It's when you essentially... when you have, you know, like your piecewise functions, when you have like x squared minus 6 is between like x is bigger than 0, then 2x minus 3 is x is bigger than 7. Something like that, and then you have like a weird looking graph where it goes like that. That's not a continuous function. Okay, and usually, like a tan graph is not considered continuous. So a tan graph is like, it's like this, and then obviously you have your asymptotes. Those are not considered continuous. It's just one single line that's considered continuous. Obviously, that's not tan x. Okay. CI will go over in a sec. You don't get it, Charlotte? As the denominator gets bigger, the fraction gets smaller. Yes? As the denominator, 21 over infinity, put a really, really big number in to your denominator, it's going to tend towards 0. Check in your calculator. It tends towards 0, right? The smallest value that we can put into a calculator, into a denominator, sorry. Well, whatever value we put, the smallest this can be, is 21 over 7. That's the smallest it can be. Does that make sense? Does that make sense or no? I need a confirmation, guys. Give me a confirmation. What is yeah, basically, yes, YB, yep. Like, it'll go towards 0. It'll never ever reach 0, but eventually it'll just get to 0. And if it's ever infinity, well, you can't really have anything that's infinity, it gets towards 0. I'm going to show you this graphically again, because I think graphical knowledge makes this a lot more easier. Because right now we're working in terms of numbers, and that's what the bigger issue is. 1 second. Plus 7. Okay, I'm going to show you guys this graphically. On the denominator, the biggest number that can be, let me make this a bit more bigger. The biggest number in our denominator is going to be 7. That makes our... No, I take that back. 1 second. Let me write this down. 21 over... Yeah, that's why I said I take it back. Okay. Max point on quadratic, I'll put max slash min, equals denominator. Okay? We're going to sub that in. This is a step by step. Then, we're going to see, okay, in this case, it's 21 over 7. That's our smallest value in our denominator. Yes? Yep. Smallest value in our denominator is 7. Do we agree? Yep, nope, yep, nope, yep. Okay. Smallest value. What does that mean in terms of our fraction? Is a fraction going to be small or smallest? Is our fraction going to be the biggest? It's if our denominator is small. Does this make the maximum value of fraction or the minimum value of the fraction? Good, Cindy. Thank you. It's going to be the maximum value of the fraction because we have the smallest value in our denominator. It swaps. Yes, exactly, Zach. Now, we found out the maximum value of the whole fraction. Now we're going to check what is our biggest value. Because this quadratic does not have its own biggest value, the biggest value of the quadratic in this case is infinity. You're just going to put infinity. As your denominator tends towards infinity, biggest value in denominator means smallest value in fraction. Yep. Yep. Yep or nope. Which is 0. However, you will never ever reach infinity. You will never ever reach infinity. That's why we're going to use the less than. So that means our g of x has to be bigger than 0, but not equal to 0, and then less than equal to 3. Because we can't have 7. 7 is allowed. Let's look at this graphically. When we look at this graphically, look, our maximum value is 3, which is 21/7. Okay, and our minimum value, if we keep on going, you can see that it just keeps on tending towards 0, but it never actually reaches 0. That's the whole essence of range and domain. Shanaz, use this. Smallest value in denominator equals the max of your fraction. Biggest value in your denominator is the smallest value in your fraction. Then you need to figure out, using your quadratic, are you finding the smallest or are you finding the biggest? That's what your quadratic tells you. Okay, write this down. And then you can use that knowledge to think about how is that relevant in terms of your range. Sometimes in your reciprocal, in this case it works. Sometimes your reciprocals might look like this. In this case it might not work. You might need to work out some asymptotes. But I think working out asymptotes is not that bad, hopefully. I think. If you guys wanted me to go over that as well, I can. So if you make your denominator as small as possible, you get the maximum of your fraction. If you make your denominator as big as possible, you get the small value of your fraction. Okay. And what you need to work out, essentially, that's what your quadratic will tell you. And you do completing the square to help you work that out. Does that make sense? It's only for fractions, but it applies to a lot of things. How can I tell from my quadratic? If you're not given a quadratic, but if you're not given a quadratic, you can still think about, well, I think in my opinion, it's easier if it's not quadratic actually. If you have, for example, 6 over, I don't know, 7 minus 2x, here it's just going to be, well, your asymptotes. What's happening here? Okay, he's just going to be to do with the asymptotes. Well, your asymptote here, I'm going to put 6x on the top even actually, because then we can have a y asymptote. Well, you have an asymptote at 7 equals 2x, at 7 over 2, right? You happy with an asymptote here? Yep. And then the other asymptote, well, our y asymptote is when our x tends towards infinity. Chuck a really, really big number, put a really big number into this fraction. What do you end up with when you put a really, really big number into here? What do you guys end up with? And actually this asymptote is wrong. When you put a really big number into x, what value do they get towards? Go towards? Not infinity over infinity, Shanaz. Actually, okay, No. Yes, Fred. Thank you. -3. Chuck a really big number into here, and you'll see that this actually goes towards. Yes, Janaz, exactly. -6/2. So -3. Okay. So your asymptote is at -3 here. So you have a reciprocal graph looking like something like, actually it won't look like that in this case, it will look more like this even. Okay, and then from there we can just work out our range. Well, you can see visually our range is going to be less than 3, so if I say this is f of x has to be less than 3 and f of x has to be bigger than 3. Or you can just simply say f of x is not equal to 3. Sorry, -3, sorry, -3. Okay. Do you see that? So it's everywhere, but it's not the -3. And if you want the domain as well, x is just not equal to 7/2. Does that make sense? Yeah, we're gonna, yep, essentially that. So to make our x asymptote. How did I get the 7/2? Just make this equal to 0, because we can't have 7/2 in our denominator. Yeah. Yes, Rico. Let me continue on. Do the parametric integration question. Which one? This one here. This one is differentiation. This one is also differentiation. This one's parametric differentiation. Which one? Let me see if I have anything else, because I don't want to spend too long on something that's collapsed. It's in general, do you? Oh, this one here. You actually want me to? Alright, calm. Yeah. Let me look at Yo-Yo's first. One sec. Because Yo-Yo sent me one. 2020 paper 1, question 14. One sec. Huh? Yo, Shanaz, are you in the Discord? Are you in the Discord? Thing is, you guys have different names, so I'm like, I know Frederico. I got. I think it's on my Instagram, but I should probably put it in the description. There is a Discord. Yo, guys, just put it in chat. Someone put it in chat. Appreciate it. A-level maths, pure, 2019. You said paper 1, right? Yo, yeah. Yeah, paper 1, question 14. This is question 13. Question 14. Oh, this looks nice. And actually, I was literally teaching this to someone the other day. This kind of topic. I was actually teaching this. I think this is a really, really good. This is actually a really good question. 2020 or 2019? You said 20. Oh, 2022. That's 20. Alright, my bad. I'll actually do. I'm gonna do this one as well in a second. Let me do your one first, here. Alright, to be fair, that's a good point. We haven't done trig today. We have not done trig. That's a good finale in the last half an hour, I think. Vectors. Yo, Harleen, send me a question. Send me the question on Insta. I can just bring it across easily. That's all. Okay. Otherwise, I'll try to find some vectors. Okay. Given that we've got 2 sine of this is equal to cos. First thing that comes to my mind is using our identities. Yo, Luke, stay for half an hour, bro. Yes, you can, Shanaz. Yes, you can. It's maths. You will get full marks whether you use like dot product or whether you use. Is it not this one? Okay. Just send me the one which it is. But if you use dot product, if you use cross product, you're not going to use cross product ever in A level, but you will get full marks. It's a valid way of maths. Is just maths. It's a valid method. It's not. There's one right answer of doing it or one right way of doing it. It's completely valid. If you end up with the same way, that's completely fine. You want to do? Yeah. Let's do this one anyways. Okay. I'm gonna put the identity down. So you have sine of a plus b is equal to sine A, this is from memory, so if I get this wrong, my bad, plus cos A sine B. Okay, and then cos A plus B is equal to cos A cos B minus sine A sine B. I believe that's correct. Okay, and then we substitute the numbers in. I'm gonna make an invite for you guys. One second. YouTube. Yeah, I'm sending it. There we go. Can you click that? You can click that. Is A/B possible? What do you mean A/B? Okay. First part, we got 2 sine of x cos of minus 60, which is the same as cos 60 actually. But you can just put minus 60 into your calculator and that should just give you an answer. Plus 2 cos x sine of minus 60. Okay. I would simplify this and this would help us get some stuff. Some nice answers. And then cos 1 would be cos x cos of minus 30 minus sine x sine of minus 30. Well, I'm going to simplify this a bit more. So this gives me sine x, just correct me if I'm wrong, plus root 3 over 2, root 3 cos x, sorry, minus root 3 over cos x. Do you need the minus 60 and minus 30? Yes, you do. Oh, you have a good point. You don't... In this case, it doesn't matter on the right one. It does. It's because it's the way you use it. You can use the numbers like this if you want. This is a completely valid method. If you decide to do A minus B, it just means that your formula will change. So this will turn into a plus 30. That will become a plus. And in this case, this would be minus, like so. Okay, they're both valid. They're both completely valid. It doesn't really matter. It's just that I was just using these plus formulas off the top of my head. Okay, but in your formula book, you will have your A minus B, which is completely fine. Okay, they're both valid. Okay, and this should end up with the same answer anyways. That's a half. That's sine x. That's root 3 over 2. That still gives you the same answer. Okay, and then by the way, you don't need to know sec, cosec. Actually, no, you might need to. But to be honest, I doubt they'll come up. The arc sine and arc tan ones you don't need to know. The sine and sec cosec ones you might. I'll go over those in a sec. This is going to be a root 3 over 2 cos x plus a half sine x. Rearrange everything to one side, and it's actually not that bad. So this becomes a half sine x is equal to 1 half plus 1. That's going to be 3 over 2 root 3. Or 3 root 3 over 2. Please correct me if I'm wrong. I'm just doing some mental maths here. Okay, so that means that sine x is equal to 3 root 3 cos x. That means that tan x is equal to 3 root 3. I feel like I've gone somewhere wrong, but just please let me know if I've done something incorrect. I'm just going to double check my working out. And we're going to add 1 plus a half. Yeah, that should be fine. That looks good. Yeah. Okay, and then we just rearrange. We're going to rearrange for, we're just going to inverse tan, and that gives us tan minus 1 of 3 root 3. Does it ask it in radians? It wants it in degrees. It's probably going to be degrees. Oh, we've done that. Well, that's good. Alright. How is that? That's alright, I think. Part B. If you're unable to do the part A, use the part A to the part B. Send it in Discord. Send it in the Discord and just give me a ping. How do we go from this expression to this? And how do we go from this expression to this? well, the change is, well, the x goes to 2 theta. Cool, okay. And then essentially we're just adding 60 to both of these terms. Very clever. Well done, Finn. So this becomes tan x plus 2 theta plus 60 is equal to 3 root 3. I'm going to rearrange for this. So this becomes 2 theta plus 60 is equal to, I'm going to inverse tan, it is in degrees, I'm going to change my calculator to degrees. This becomes the following. It's 123.95, don't like that. Is that all of our answers? It's not just going to be all of our answers. Reason being, we need to adjust our range. You can see that this range here is 0 to 180 degrees. 0 to 180, so we need to just slightly adjust it. So if I adjust this to 0 to, let's do 0 to 2 theta for now. Okay, and let's add 60, so we get 60 to 2 theta plus 60 is less than 420. This is our actual range. So we need to think about, okay, what are the values that fit within this range? Well, when we're working with tan, we can just add 180 each time. So that's one of our values. If I add 180 to this, this gives us this as well, 303.95. And I believe these are the only two values. These are the only two values that could work. Okay, and then we're just going to rearrange both of these for theta. So that means that this first one is going to equal to, let me quickly work this out. Answer minus 60 divided by 2. That gives you 31.9 for the first one. And the second one, 303.95 minus 60 divided by 2. And that gives you 121.95 as well. 0.97, sorry, 0.9798. Okay, these should be your two values. If there's any questions, just let me know. I'm gonna read back the chat. What the heck is going on? 3 calculators. You do not. Trust me, you don't need 3 calculators. And make sure you're never in gradients. The most clap thing. I've seen someone seen a TikTok. You think you should prioritize getting revising maths if you're getting content 88 plus in core? I say I prioritize other stuff, Harrison. I'm not gonna lie. It's really down to you to see. Okay, should I do like more maths? Do you want to get more comfortable with maths? I think you should focus on applied. Get that up. Pure, if you're doing 86, 88, that's really good in my opinion. And A-star will never, I don't think should ever go around that area anyways. I think A-star probably will range around 78-ish%. What was I getting on my papers before my exam? I was getting good, let's just say that. Not gonna flex here, man. Zachariah, yeah, let's do some 3D vector. Let me find some stuff. The power integration question. Oh yeah, wait, oh yeah. Let me do that. You know, I'm not in my prime anymore though. I'm gonna be honest. My prime for maths was crazy. I'm actually not in my prime anymore. Yep, here you go, Ellie. Your wish has been granted. Huh? Who did that air? Who? Lexi, you can get it, but to be honest, I'd avoid it. I'd avoid it at this point. Unless you can learn it. Finn, why do we have to adjust the range? It's because we've got 2 theta plus 60. If we don't, then what happens is we won't have the valid answers essentially. Okay, so we need to think about, well, what values fit within this 2 theta plus 60, which is within this range, and then we can adjust that back to just theta by doing minus 60 and then divide it by 2. Okay. You guys want to try this question? There's like, try it. Can you not minus 60 divided by 2? Yeah, you can. But you will have multiple answers, Finn. That's the thing. You will have multiple answers. You can't do that right from the beginning. You need to get your multiple answers first. Alright, we'll do that balloon one in a sec. Let me send that to myself real quick. You're very Alright, calm. Say no more. It's pushing 7 o'clock though. I can push a bit more forward. But yeah, I've been literally teaching all day since 11 o'clock actually. But yeah, that's. Alright, let's start this. Let's see how this goes. Alright, first thing, it says dy by dx. So, dy by dx. What is that going to be, dy by dx? Well, we have dx over dt. We have this, and we can do dy by dt. Well, we have dy by dt times by dt over dx, and that will give us dy by dx. Okay. I actually can't remember the last time I did parametrics, I'm going to be honest. But yeah, let's go with it. Tan, you need to know. Actually, you don't need to know. It is in your formula book. But tan does differentiate into sec squared. So knowing that, being comfortable with that, it will help you just save time. Okay, someone asked me what's the difference between d over dx and dy over dx. Is this when you have a y equals something, you use dy over dx. When you have an expression, it's just d over dx. I'll check for you, Cindy. I will check for you. See if you can simplify that a bit more. Because you have a sec t in your denominator. See, to be fair, you have that, don't you, right? Let's see. Well, this is going to go to root 3 sec squared t plus pi over 3. dt over dx is just going to be, from memory, sec t tan t, I think. I'm going to formula book for that. Edexcel formula book. Can someone confirm the sec t differentiate to sec t tan t? For implicit, do dy by dx. Thank you, Yo-Yo. Okay, cool. So we're just essentially going to times these together. Honestly, I think you could probably leave it like this. They haven't given a specific kind of form. But to be honest, I think they would want you to clean it up a bit more. I would probably expand this out because a pi over 3 would turn into, well, you can work out that. So I would probably use your identity and clean this up a bit more. But it doesn't really say, so honestly I'm going to leave it like this. You could probably leave it like this. Should I clean it up? Or nah? Should I leave it? No, ask you guys. I need to find the formula book as well real quick. Okay. It's not parametric integration. Should I clean it up? Because you were right, dy by dx, because you, yeah, 30, yeah, you're right. You would, when you differentiate a y goes to dy by dx. Flip the sec t tan t is under 1. Oh yeah, you're right. Absolutely right. 1 over sec t tan t. Absolutely right, Imad. Absolutely right. I'm just thinking about if I just clean it up. I'm just trying to look at this this other question that Yo just sent me. I will put this down here. And then Mario sent me as well. How did I differentiate y so quick? It's because tan differentiates to sec squared, Rizla. Such a funny name. Tan differentiates to sec squared. Everything else remains the same. The inside brackets, it just differentiates to 1, so we don't need to worry about anything. Okay. Sec t is in your formula book. Sec t differentiates to sec t tan t, and we're just going to flip around dt over dx. Okay, you know, I'm going to clean it up because it's irritating me. Sec squared is the same thing as 1 over cos squared. Okay, I'm just going to work out at the moment what cos t plus pi over 3 would be, which would be cos t cos pi over 3 minus sin t sin pi over 3. And whatever this is cos 60, so that's going to be a half cos t sin 60, that's root 3 over 2 sin t. And I put that as a square, that looks better, I think. And then I'm going to bring that as a denominator, like so. Actually, I can't really, I'm going to have to expand out and stuff. Yeah, you know what, I'm leaving it like this. I'm leaving it like that. I'm leaving it like this. Okay. Part B, find an equation for tangent to C where t is equal to pi over 3. Or we just sub in pi over 3 for this, really. So pi over 3 we're going to sub in for part B. So we have essentially root 3 over cos pi over 3 plus pi over 3, which is 2 pi over 3, times by 1 over sec pi over 3 tan pi over 3. It depends. It depends, M. If they don't ask you, and usually they will ask you, they'll tell you to give it into a form. They'll give you it as like a show that it's blah 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 form, or usually they will give you the form, so you'll clean it up automatically. Okay, in this case it just doesn't, which I guess you're kind of forced to leave it like this. Yeah, I think this is probably a better form. This is probably what the mark scheme would be saying. But as much as you can, try to, because then your part B might be helpful with it. Sometimes there's no need. Okay, whatever this value gives you in the calculator, you can probably just sub this right in. Cos of 2 pi over 3 off the top of my head is cos of 120. Cos of 120 would look like, if 60 is there, 120 would be here, so that will be minus a half, I believe. Correct me if I'm wrong. So that's going to be minus 2 root 3. Okay, times by 1 over sec pi over 3. That's going to be, I'm just doing this in my head. That's a half, so that's going to be 2. Tan 60 is, no idea. You don't, what, tan addition formula? Does it match the tan addition formula? Does it? 1 plus sec squared, where? Yeah, but you still have this in your, you still have it in your thing though. There's no need in this case. I see why you're saying that, but we'll have like a tan of t plus pi over 3 still though, and that doesn't cancel out with the tan t. I can see why you said that though. I'll leave it like this for now. If we need to clean it up, we'll clean it up. At the moment I'm just substituting the numbers in. You can substitute into a calculator. If anyone has done that, that'd be nice. Otherwise I'm just stuck doing it in my head. It's tan of pi over 3. In degrees. Radians. Root 3? Yeah, being Fortnite. I'm still alive. Gonna be going off though in a bit. To root 3. And this actually does cancel out, which is actually very interesting. Which gives you -1. Very cool. So our gradient is -1. Calculus is always radians. Yes, it is, Cindy. Very good question. It is always radians. For trig, yeah. I might be doing one later on, maybe next week. I mean, start the session, I can't lie, was a bit rusty. I think I might lower the difficulty if I'm going to teach that tall questions. I think having math scheme, I think makes just the teaching a bit more smoother. Okay, and then essentially we're just going to substitute the x coordinate and y coordinate in. How do we work out the x and y coordinates? We're going to essentially take our pi over 3 into here to work out our x, and put the pi over 3 in the y as well. Sec of pi over 3 we already worked out was 2, so that's going to be 2 is equal to minus, sorry, that's wrong. X equals 2. My y coordinates, how do I work out this for my y coordinates? I'm going to put pi over 3 into here as well. That's going to give me, I'm going to put that into calculator. Essentially, if you put pi over 3 into this should give you a y coordinate, and you should just end up with the following. You should just end up with -3. Good. M is -1. Yep, M is -1. So if your y coordinate is -3, x is 2. How did I work these out? I've just substituted my angle, my t equals pi over 3 into both of these. That just gives me my coordinate. So then I can substitute it into my y equals mx plus c. So -3 is equal to 2 times by -1 plus c. So that gives me c is also equal to -1. So that's going to be my tangent equation. Y equals -x -1. Okay. I hope that makes sense. Cool. Alright. Let's look at part C. show that all the points are satisfy the equation. Satisfy the equation. Here I'm assuming they've kind of made a Cartesian equation here, and they've combined it together. We've got y equals something. Here you'll probably be using your tan formula most likely. Here most likely will be a tan formula. So I'm going to pull out the tan formula. It's the first time I'm ever using it in my life. What's our tan formula? Excel formula book, A-level maths. Let's pull this out. If you guys have any questions still, please ask. Give me a sec. Where's it? I got it. I got it. There you go. That is the tan formula. What's the Discord link? Discord link, I posted it earlier. Ooh, what's happened here? It's calm, I think. Potentially Imran, I'm just checking Discord, sorry, I'm just looking at Discord right now. Alright, cool, that's fine. Potentially next week I'll try my best. Okay, which point were we at? We are essentially taking this y equals formula and we're trying to convert it into a Cartesian. So I'm gonna sub all the numbers into my tan formula here. Let's see, we're gonna try to see where this takes us. So we got root 3 tan. Well, a is t and b is pi over 3. So we got, I'm going to put this as a formula, sorry, as a fraction. Tan t plus tan pi over 3. 1 minus tan t tan pi over 3. Well, tan pi over 3, we already know is 2, I believe. No, it's root 3, I'm way off. Plus root 3, and this is going to be root 3 tan t. But we're timesing this by root 3, so this becomes the following: root 3 tan t plus 1 over that. Now this feels like it could factorize in some way. It just looks like it factorizes in some way. Root 3 tan t minus 1. I'm going to leave it like this for now. We know x is equal to sec t. Hello, chocolate chip. How you doing, man? X is equal to sec t. We're going to substitute the x into here somehow. Well, we know that using our identity, tan squared plus 1 is equal to sec squared. But if we square root that, I should probably do it the other way around. Tan squared is equal to sec squared minus 1. You guys can't see that. That means that square root of tan, or tan x, is equal to square root of sec squared x minus 1. Oh, so Leo, how you doing, man? How you doing? Of course I remember you, bro. Of course, you're my Discord mod. And then we're going to substitute all the numbers back in. The reason why we did this is so we are able to convert. That's the linkage between sec and tan. How does the gradient become minus 1? Because tan, tan differentiates to sec squared, but the reason why we got sec t tan t is because your x equals sec t here differentiates to sec t tan t. I'm doing good. Okay. Now we've got tan x in this type of expression. I'm going to rewrite this as the square root of x squared minus 1. So I'm going to rewrite this as the following. Root 3 x squared minus 1 plus 1 over 1 minus root 3 x squared minus 1. We are missing an ax squared on the numerator, which is a bit interesting, but let's continue on. This is going to be the following: 3x squared minus 3 square root plus 1 over 1 minus 3x squared minus 3. Do you simplify it? Yeah, I have simplified it. Yes. The gradient should be minus 1, Arib. Gradient should be minus 1 if you guys are still on the part A. Okay, and we can actually leave it like this. Actually, it does want it in an ax squared form. Let me see what we can do to convert. Oops. Did you see? It says 2. I might have done something wrong then in my calculations. Then 1 sec. Let me have a look. Root 3 sec squared t plus. Yep, over sec t tan t. Let me check my numbers. I'm gonna put it into the calculator real quick. I might have just multiplied it out wrong. 1 over cos 2 pi over 3. Okay, that gives you minus 2. Oops, no, it doesn't. Gives you 4 root 3 on the numerator. Yeah, that might be why. And then I forgot to square it. And then yeah, it's probably because I forgot to square it. And then that becomes sec 1 over cos pi over 3 times by tan pi over 3, which is 2 root 3 over 3, or 3 root 3 over 2. That cancels out. Just give me an 8. Now, because I was using manual numbers in my head, that's why. I'm just seeing if that is supposed to be a squared. So that's supposed to be minus 4 root 3. So minus 2? Is it 2 or minus 2 you got? No, that's supposed to be positive 4. So yeah, positive 2. Yeah, positive 2. Positive 2, yeah, positive 2. Yeah, because that's supposed to be a squared. That's supposed to be a squared, so that's positive 4 root 3. So that's positive 2. Yeah, you're right. Alright, I think that's enough maths from me today. I hope it was helpful in any sort of way. I know the start was a bit rusty, but I appreciate the patience, guys. It is my first live, like at the scale as well. So, but yeah, Zach, my bad, bro. No, join the thingy right now, man. Join the Discord right now. Yo, I'm tired, man. I'm tired. And it was differentiation. It was differentiation. It was not integration. I thought, what's it called? Fred said it was integration. It was differentiation. I don't know, man. I will resend it in chat. Hannah, I will try my best. I cannot guarantee as much as I want it to be. It might not. I will try my best though. I'll have to see if it's recording. I think let me check if it's recording. Oh, getting some notifications. Because I know people are joining right now. The Discord. Is it letting you guys join? Or is it giving you some sort of error? For part C. I haven't got the answer for this, bro. Imran, I haven't got the answer for it. I didn't complete part C yet. I'll jump back to part B. You know what, let's complete part C. Let me complete part C and we'll finish off here. This is what I've got so far. I'm gonna check this real quick. So that all points satisfy this. We've got root 3 tan t. I'm going to check the formula again, just in case I've substituted anything wrong, because I've definitely made an error here. We've got root 3 tan t plus tan root 3, which is just root 3. So pi over 3. 1 minus root 3 tan t. Yep, that's cool. Now we know that x equals sec t is the same thing as tan x is the same thing as square root of sec squared x minus 1, just using our identity here. So that means this gives us square root of x squared minus 1, and I've just substituted that in, and this should actually be a root. Yeah, that should be a 1, that's fine. That becomes 3x squared minus 3 plus 1. Am I going to upload the live? I will try. Over the denominator, which is 1 minus root 3, which gives us this. It's something that's 100% gone wrong. Actually, no, it's not. It's the way that this is formed. So actually, I'm gonna go down here, and I noticed this right at the beginning. Where's the plus 1 from? It's because root 3. I've just times root 3 across. So root 3 times root 3 gives me plus 1. That's why it comes. That's why that comes, Charlotte. It should be, look here. It should be. Okay. Now we need to essentially convert this form into this form in some way, and what I'm seeing essentially is that this is linked. You can see that this is very, very similar to this. You see, this is a 1 plus on the top, and it's a 1 minus on the denominator. So what first? Plus 3? Is it plus 3? Have I messed up somewhere? Where have I messed up? Ah, yeah. My bad. Okay. Okay. No, that looks good. That looks a lot better actually. Where can we go from this to get to 4 minus 3x squared? First thing that comes to my mind is actually doing some rationalizing denominator. That's the first thing that comes to mind. So I would probably multiply this by, so is mine, Kit. So is mine. I would probably times it by this. That's the first thing that comes to mind, and that would probably help us in the numerator as well. I'm going to rewrite this fraction, this square root bit, into kind of a u, and this might help us a little bit here. So I'm going to call, let's say u is equal to 3x squared minus 3. We're not doing no differentiation, no integration. I'm just making this a bit more easier to write. Okay, so this will be 3 over u, 3 plus u, 1 minus u, times by 1 plus u, 1 plus u. This is going to be the same thing as u squared plus, see you later, Salil, 3u plus 3 over u squared minus 1. Okay, we know that u is equal to this. I'm just going to bring this back. This will just be a bit more easier to simplify. This is going to be the same thing as 3x squared minus 3 plus 3x squared minus 3 plus 3. And you can see this cancels out on the numerator, but I'll clean that up in a second. This will be 3x squared minus 3 minus 1, which is minus 4 on the denominator. This simplifies to that, and we're just left with this. And does that match? It does match, which is nice. Finish off here. Cool. That was a hard question. It's a hard question. Okay. That's nice. I can't. My brain is finished. I'm actually tired. No, well done, guys. Well done for your patience. Is there a live tomorrow? Hell no. Okay. Want me to do another 3-hour lesson tomorrow? Crazy. I'll probably do one next week potentially, hopefully. But yeah. We rationalize. We do a rationalizing here, and I can't. It's actually pretty tricky to spot. Chem. I really want to do chem next. Let me check my calendar. Next. What is it? Next Thursday? No. When is chem? Is chem the 10th? Chem is the 10th, right? Chem is the 10th of I can't teach bio, bro. I'll bio, man. Chem is the 10th. I'm thinking to do some inorganic for AQ. I'm gonna do AQA though. I'm not gonna focus on OCR that much. OCR can still learn, but it's gonna be mostly chem prioritized because I teach chem and bio, chem and maths, not bio. Why would you do bio? What do you want to do bio, man? Kevin's gonna be mostly for AQA though. It can be OCR as well, like they're very very similar. Mostly it's gonna be AQA, but it's gonna cover transition metals, like that's part of inorganic. I'm not gonna do any rates. To be fair, rates is alright. To be fair, don't worry about organic right now. You know, is organic paper 1 for OCR? Cannot remember off the top of my head. OCR paper 1. Chemistry. Let me have a look. One sec. 2017. Is it organic? It does have organic in it. Can I do acids and bases? Is paper 2? Yeah, I know organic's paper 2 for AQA. What about for OCR? No, it's physical. It's physical inorganic as well. It's the same. Yeah, it's the same. That's calm. Yeah, we'll do some chem next week, inshallah. And yeah, man. Thank you guys for coming. Join the Discord if you haven't already. Let me post that in the chat again. One sec. Switch accounts. Boom. Yo, I'm on 100 subscribers. Love you guys, man. Absolutely love you guys. I'm gonna post some more videos though. 100%. Alright. Alright, there we go. There we go. It's not pasting. There we go. Boom. Alright, join that, yeah? I'll see you guys in a bit. See you later. Bye-bye.